Assalamualaikum and a very good day to my partners, Teknologi Sulaiman bin Sabikan and Teknologis Muhammad Hanif bin Cik Hassan. This is my Bachelor degree project 2 presentation. My project name is Autonomous Navigation for Agriculture Robot using AI-based method. My name is ILYAAMEERA AQILAH binti ATTAN. My matric ID B0818104191 and I am under supervision of Puan Rozilawati binti Muhammad Noor. So this is my BDP poster that's abstract, the introductions and the others. So we will start with the abstract. The agriculture robots, they are automated, decrease labor expenses, keep workers from performing risky jobs and offer farmers with up-to-date and precise information to help them make management choices. Designing appropriate system for sensing, obstacle avoidance and line following is the focus of research on mobile robot navigation system in agriculture situation. The navigation algorithm must utilize sensory data to identify an appropriate trajectory, make a choice, and effectively winding its rounding without colliding with anything. In this paper, an overview of autonomous navigation for the agriculture robot is presented and discussed. This project will present the use of neural network that will be trained to give output control commands from image input data. So for the introduction, in these recent years, the pandemic will have the greatest impact on poor nations that rely largely on food produced by small farmers, livestock producers and fishermen. Therefore, in the present, robotic application and autonomous navigation need to be practiced to continue the agriculture sector. The agriculture sector is undergoing a transformation that appears to be very exciting as it will allow this primary sector to reach new levels of farm productivity and profitability. Agriculture robots must be capable of navigating agriculture plantation precisely in order to maximize efficiency and prevent destroying crops. In this project, it was based on using neural network in the category of vision-based sensors to learn data from robot movement. So what is deep learning? Deep learning is a subset of machine learning and machine learning is a subset of artificial intelligence. The deep learning is characterized with how an algorithm may learn from seeing and making decisions based on its experience. Deep learning algorithm must use for computer vision, natural language processing, speech recognition and processing and a variety of other applications. Deep learning is concerned with how a computer software may learn and by seeing and making judgment based on its experience. So the objectives for this project is first, to design a deep learning-based robot navigation algorithm inside chili plantation farm. Second, to develop a forest robot for agriculture. And the third, to analyze the line following performance of the agriculture robot on the proposed applications. So the scope is by applying convolutional neural network, which includes of the open source software TensorFlow and the programming language Python. Images are captured using a camera and neural network is used to train the model. This project uses Nano to run the agriculture robot automatically. This project is designed to be used in chili farm. For the methodology, this is the flowchart. The flowchart is important to add as a guide for this project to ensure smooth running project throughout the entire implementation phase. For the first phase, the layout and problem head planning and identify out. The size of the robot is measured by considering the size in chili farm. Next, the robot will be developed based on the layout planning. To complete this project, it had been divided into two phases. Chatbot is using as the first phase to train for this project. The open source chatbot AI robot platform gives us everything we need to build AI applications. It powered by the Nano, which support multiple sensors and neural network in parallel object recognition, collision avoidance, and more. The chatbot is tested by the collision avoidance and road following. After success for the first phase, then proceed with second phase, which the electrical components from the chatbot will transfer to the actual rover. Nano will connect it with motor driver MDD10A. The program changed due to the changes of wheels from 2 to 4 wheels. For the algorithm part, the pictures of various sites in chili farm will be taken and place it in the Nano for the image processing. By using convolutional neural network, the camera and robot can cooperate to follow the path along the chili farm. After the successful of the algorithm, all parts of the rover body will be implemented and they will be tested. The finishing product will be following by analysis and the report of the final project. So this is the picture of chatbot for the first phase that I try to train the data, and this is when I implemented to be a rover for the farm. So this is the block diagram. The system for this project works in the way that firstly, all the images in the chili farm will be taken as the input data. All the images are added as the inputs that consist of various row lines, such as straight path, right path, and left path. All the inputs will be trained with several hidden layers in neural network until the system recognizes each of the captured photos. When the rover moves, the camera will sense the environment of the farm or the path. Next, the command will be given to the examiner and the receiving command to move the rover either goes straight or to left and right goes to DC motor and it moves to the wheels to rotate. So this is the hardware requirement for the rover. There's a camera in front of the rover and the Jackson Nano inside, connected with Arduino Uno and connected with MDD10A motor driver. So this is the output view that shown by the robot. So the objective of the rover movement autonomously is achieved as the rover can move based on the vision based using neural network ResNet 18. It uses camera to capture data, neural network train the data and send information to Arduino Uno and MDD10A, and then to HBridge, which controls the working of the wheels. So as a conclusion, this project was said to be successful. The result of this project is achieved as the agriculture robot can move autonomously in the farm. The Jackson Nano acts as a powerful computer that can run AI workload. All data will be trained using neural network. In the future, this project could be improved in the future with different dataset can be chosen to test the performance of this robot. This architecture robot can be added function to act as the robot that can spray fertilizer, spraying water, picking fruit, and many more as this robot can move autonomously. This robot can be permanent at one farm as when it collects more data to be more accurate and on its movement and can perform well. The implementation of technology in our country is a must and we need to prevent our country from left behind in industrial revolution. The contribution of IR 4.0 in Malaysia will ensure our country provides better services in the future, besides increasing the number of skilled workers and producing higher value-added products. So let's go for project demonstration.